in just a second. All right, everyone, we're going to go ahead and get started. Thank you so much for being here today at our seminar. My name is Cinnamon Moffitt, and I'm the Research Program Manager here at Oregon State University's Hatfield Marine Science Center. For some of the folks that I do not recognize in the room today, thank you so much for being here and being with us. We appreciate having you here. Just wanting to let folks know this is a hybrid event. So that means we have folks online and folks in the room. For folks online, we do have your cameras, mics, and screen shares disabled, but we have a wonderful volunteer, Roseanne, who is here monitoring the chat. So if you have any questions or any technical issues, you can put them into the chat box in Zoom, and she will help you navigate those or read those questions out at the end to today's speaker. For folks in the room, just a reminder, please sign in. We have a couple reasons for that. That sign-in sheet is just outside the door. That helps us buy you cookies and coffee. It also gives our outreach numbers to our speakers. So if you can help us by doing that, go ahead and log in. Okay, before we get started, I wanted to make another announcement. On April 7th, we have somebody that several folks in the online audience might know. We have Brian Black coming back to Hatfield. He currently works with the Laboratory of Tree Ring Research at the University of Arizona, and he's going to be doing a talk next week's seminar about the extreme climate and natural disasters of the Pacific Northwest. He's also hoping to do some sabbatical time with us in the fall. And so he's going to hold office hours before and after his seminar next week in the Liver and Weber room, I believe. And so if you are interested in collaborating with him or learning a little bit more about his research, you can come by and visit him at his office hours. I'll be sending out an announcement to the community list tomorrow with those details. So if you're interested in connecting with him, he's an amazing researcher and has really cool work that he's doing. So I'm hoping the Hatfield community can show him how excited we are about his research. But the reason you're all here today is for today's speaker. So let me just do a quick introduction. Laurie is with the Lamprey project, or she is the Lamprey project leader with the Columbia River Intertidal. Yeah, I'm just not doing it today. Too many things. Okay, I'm going to try again. The Columbia River Intertribal Fish Commission, and Laurie's worked with them since 2015. Her focus has been on implementing the objectives of the Tribal Pacific Lamprey Restoration Plan for the Columbia River Basin. She works in close coordination and collaboration with the technical and policy staff with the CRITFC tribes, which is the Umatilla, the Nez Perce, the Yakima, and the Warm Springs, in support of the Pacific Lamprey and the mission of the Fish Commission. Laurie's goal is to increase public awareness of the Pacific Lamprey and its important role it plays in contributing to the health and function of the ecosystem and for their cultural significance. Laurie holds a bachelor's degree in biology and a master's degree in cultural and natural resource management from Central Washington University. Laurie is also a member of the Lakutare tribe and enjoys learning the Ojibwe. I was practicing, and that's why I'm nervous. Language. And so we are so excited to have her here to share with us some of her work. And so Laurie, the floor is yours. Go ahead and take it away.
All right.
Mic turned on?
Mic is turned on. Can you hear me? All right, perfect. All right, well, thank you for the introduction, and I'm happy to see everyone here today. So we'll get started. So the title of my presentation is Pacific Lamprey Restoration in the Columbia River Basin and Monitoring Success of the CRITFC Tribes Translocation and Restoration Programs. Now, there we go. There we go. Okay, so I'll tell you a little bit about the Columbia River Intertribal Fish Commission, and then I'll tell you about my particular project that I work under, which is the Lamprey Project. Then we'll move into a short video that'll describe about Pacific Lamprey. And then after that, we'll do a little bit of go through some of the monitoring success that we've learned through genetic sampling. We'll wrap it up with a slide that has opportunity for questions. And I also will go online on the CRITFC website and show folks how to find the jobs, et cetera, at CRITFC in case folks are looking for employment in the future in fisheries. So, okay, so CRITFC. CRITFC was formed in 1977. It's the member tribes or the Confederated Tribes of the Umatilla Indian Reservation, the Confederated Tribes of the Yakima Nation, the Nez Perce Tribe, and the Confederated Tribes of the Warm Springs Reservation of Oregon. Now, this was established in order to provide coordination and technical assistance to the tribes. Now, the mission is very important. The CRITFC mission is that to ensure a unified voice in the overall management of the fishery resources, and as managers to protect reserved treaty rights through the exercise of the inherent sovereign powers of the tribes. Now, we accomplish this in several ways, but the four main is putting fish back in the rivers and protecting the watersheds where fish live. And that's what this presentation is going to be about. Protecting tribal treaty fishing rights, sharing salmon culture, and providing fisher services. And this photo is the late Nez Perce tribe elder, Elmer Crow. He's presenting at the lamprey, at the salmon camp, and he's discussing lamprey, so he's sharing culture. And just as an FYI, CRITFC does a salmon camp annually for the CRITFC member tribe youth, and a really interesting ability to share through generations. Now, putting us in geography here, where are they at? So this is where the Columbia River Basin is what I'll be discussing today, and the CRITFC tribes locations where they reside, their homelands. Also of importance is the dams on the Columbia River, the mainstem Columbia. And so a lot of our work is in setting traps at the Bonneville, Dalles, and John Day Dam. And then we transport those fish upriver to the 3 tribes that translocate. And then when I get into the genetics monitoring, I'll talk about how we predict larval abundance at the lower Granite Dam. So with that, now we have it's a positive presentation today because we're going to talk about this projected possible 400,000 lamprey adult returns to the Columbia River to Bonneville Dam, possibly by 2027. And this is partially due to the translocation program and all the other efforts that have occurred. So this is a message of positivity, hope through action that we can improve things. And so I want to start us off with this wonderful video, which just kind of puts us in place and time and what we're doing. And it's about 5 minutes and 20 seconds. Okay, and then I'm going to move it over here.
They gave themselves up so that we could live on this world.
We'll get it.
These fish play an important role, and not just to the ecosystem, but play an important role in our life and our culture.
What you call lamprey, I guess I grew up hearing all of our old people call them eels.
He was a good food source. He was easy to catch. He was plentiful. Spiritually, he's one of us.
It was part of our daily life. It was part of our growing up. We just never thought of it and maybe took it for granted that we would always have this rich natural resource available to us.
Lamprey were once very abundant in the entire Columbia Basin and tributaries of the Columbia Basin. They were known to be, their range extended all the way up into the headwaters of the Columbia, all the way in the upper Snake Basin. Now lamprey are only really present in the mid-Columbia and the lower Columbia River.
The decline in these animals over the past 20 years is astronomical.
They've been here for hundreds of millions of years. But it's only going to take 100 years to wipe them out.
In one short lifetime, in the whole, since the earth has begun, since these animals became available to us and became our brothers that took care of us, and in one short lifetime, they've almost disappeared.
How do we let something that's 450, 500 million years old go extinct? Shame on us, the whole bunch of us, for not paying attention to what was going on.
There are times that I worry that I would sure hate to see the extinction of a species in my lifetime.
People better realize what they're doing, because we are a big family. We are the circle. That's what life is about. We take care of one another. So when we have someone in trouble, that's where the rest of us have to step in. You want to see him? There he is. There he is. You want to meet my friend? We'll go to the dams. We pick the eels up. Take them inland where our home country is. We take them to the streams we want. We put them in the water. The rest is up to them. They amaze me. They are amazing creatures. They just my brother Eel's cool. He just flat cool.
All right, so I like to start with that, as it just kind of brings us to place to what we're working on and the reason we're doing what we're doing. And so it was a call to action at the time that this was released, was about 2012. And that brings us to our tribal Pacific Lamprey restoration plan, the Columbia River Tribes Translocation and Restoration Plan. And the purpose and goal of the plan, so they found there's an urgent need for urgent action. So folks came together, developed these plans, and we began implementing it. We made big goals. So I just want to read the plan vision, that Pacific lamprey are widely distributed within the Columbia River Basin in numbers that fully provide for ecological, tribal, cultural, and harvest value. And right now we're undergoing an update on this plan because, like I said, it was released in 2011. And so if we look at the numeric goals from that time, in the Columbia River Basin, we have halted the decline in a sense. We have started the translocations. So we're seeing some increase in larval abundance, et cetera. And then, like I said, I'm going to talk about the increase in adult returns. We did not meet our 2020 goal, and that's okay because we're we're now shooting past that. We're going to go for something bigger. We didn't meet it, but we're working on what we're going to meet in the future. So, but the important one is restore lamprey to sustainable harvestable levels throughout their historic range, where they can provide ecological, cultural, and ceremonial inputs. So moving forward, the objectives that we implement from the plan is, this is the work that is conducted on the ground is pretty much within those 6 objectives, and they each address one of the critical threats to lampreys. And so we're looking at fixing mainstem passage and habitat, fixing tributary passage and habitat, implementing supplementation and augmentation. That's what we'll talk about today. Contaminants and water quality, public outreach and education, and then research monitoring and evaluation, which is the genetics piece. So for folks who aren't familiar with lamprey, you heard in the video, they're 450 million years old. They've been around that long. They've survived every mass extinction. So, you know, we can't let them go extinct during our lifetime. It's absolutely, it's not going to happen, and we won't let it happen. But they're really interesting fish. They lack jaws, they lack bones, scales, paired fins. They breathe through their 7 gill openings. You saw that one breathing there. And they're distributed throughout the Pacific Rim, all the way from Baja, Mexico, up north, Alaska, around Russia and Japan. So they have a wide distribution. And so they're exposed to a lot of threats throughout their ranges. And so life history, just a brief rundown of their life history. They are anadromous. They return to fresh water to spawn. They have some different characteristics. They do not home the same as salmon do. So they don't home to their natal stream. They may home to their basin or what have you. And so it makes it a little trickier to track whether or not you're successful in your work. But we're beginning to get those details through the genetics. Anyway, so they return, there's 2 different types. Some will mature in the ocean, and then they'll spawn right away the year they return. Others, the ones going up to the upper Snake River, generally will overwinter at least 1 year, possibly 2, sometimes up to 3 before they spawn. So they do their migration, they find a big cold pool, they just hang low for a while. When they lay their eggs, it's up to 250,000, and those will hatch about 19 days. They are eyeless. They don't have teeth at that period of time, and they burrow into the sediment. They'll stay in the sediment 4 to 10 years before they transform and make their way out. Those years can vary slightly. Some could leave earlier, some could leave later, but that's about average. And then once whatever key it is, whatever something creates they begin their metamorphosis, and at that point they'll be ready to head out to the ocean. They'll get their teeth, their sucking mouth, and their eyes, and then they'll make their way to the estuary, at which point then they'll latch on to one of their many prey, and they'll be out in the ocean. And so then they're carried around based on what they've latched onto, so kind of distribute widely. And then their ocean phase is also quite variable. So I think I already said, some may stay out there in the ocean not even a full year. Some will be out there 6 years, and then there's a wide range in between. So, all right, so why did we need to begin translocation of fish, which translocation is basically for Pacific lamprey. That is, we trap these fish at the Bonneville, Dalles, and John Day dams, and then we transfer these fish to the 3 translocation tribes, so the Yakima, Nez Perce, and Umatilla. The Warm Springs tribe is not doing translocation at this time. They do different passage studies and what have you, so sometimes we'll pass off some fish to them. But after dams were built, the lampreys have trouble passing the dams. You know, they were not designed for lamprey. They were originally designed for salmon. Now the Army Corps of Engineers has been working through the Accords and other agreements, and we work collaboratively and coordinate on improving passage, and a lot of work's been done, but a lot still has to be done. But so you can just see from the counts here why, you know, the difference between long ago. It used to be millions would be in the Columbia River. Now we're into the hundreds of thousands to not even 100,000s. Okay. And then this is a 24-hour count. So the previous one was the day counts. The 24-hour, they move at night more than daytime. And so this is a 10-year average. So there was one year with a pretty high run. That was 2017. We actually surpassed our 200,000 goal that year. And there's a pattern too. So it has to do with the ocean, we believe. You know, we're still trying to determine everything, but it's on the upswing again. So that's good. Now, here's an issue. The reason why we pick them up at the dams and then truck them upriver is just for the mainstem dams. They'll have to get to the Upper Snake River Basin, they've got to get through 8 dams. So you can see about 50% of the lamprey counted at Bonneville will be counted crossing the Dalles, then less than half of those onto the next one, and half and half and half. So by the time you get to the Lower Snake River dams, you know, look at my scale here. Not even 500 fish in many of the years make it up there. So for now, as we call it a stopgap measure, it's not considered to be permanent and forever. I mean, the goal is that with all the fixes that are being done and other ways that we can get those fish up there. All right, so this is a map just showing you the range of where fish are collected, released, the dams we collect at, also where we do e-fish surveying and the screw traps and etc. Just to kind of put, oh, and then on the ocean there, that's where we collected samples from the groundfish and hake surveys. NOAA collected them, and we get genetic samples off those fish. We've translocated 53,000 fish since translocation began. That's pretty good. Okay, goals. The goals for each of the tribes are very similar. So the Umatilla is that they started the translocations first in the year 2000, and their goal was to restore natural production of Pacific Lamprey to the tribe's ceded basins to self-sustaining and harvestable levels, and to evaluate the success of restoration to inform management and for potential application elsewhere. So here's the number of fish that they have translocated over the years that shows the collections from Bonneville, the Dalles, John Day, and the total. The last few years, we've had record collections and releases in compared to the previous. So, and like I said, the Umatilla tribe is also doing artificial propagation and has just begun in the last 2 years releasing larval, doing outplantings. Now, the Nez Perce tribe was the second tribe to begin translocation, and being that they're the farthest upper reaches of the lamprey's run, they want to thwart further local extirpations, prevent loss of pheromone migration cues from larval lamprey, maintain some level of production in the Snake River Basin until mainstem passage improves, restore lamprey-related ecosystem values, to promote diversity, productivity, and ecosystem health, preserve cultural values of lamprey. And then you can see they began in 2006. We try to equally divide among the 3 tribes. And then the Yakama Nation was the last to start with the translocation. Their goals are to restore natural production to a level that will provide robust species abundance and significant ecological contributions, meaningful harvests throughout the Yakama Nation ceded lands and in all the usual and accustomed areas. And then here you can see their translocation over the years. All right, and then the Confederated Tribes of the Warm Springs Reservation of Oregon. Like I said, they're doing a lot of work on escapement estimates. They do abundance monitoring and various other restoration and other work. Now, just to talk about our record collection in 2023, it was a collection of 11,022 fish over the migration season. We start putting traps in around 1st or mid-June, and we pull traps about when the run trickles down to about first week of September. So we have the crews going 7 days a week. The traps are running 24 hours a day. It's a lot of work to keep it rolling. And then our 5-year summary of how many we've collected. Some of our, we're getting better at easier collections, collecting more fish, but not, the percent of the run is remaining about the same. And we collect based on the tribal Pacific Lamprey Restoration Plan guidelines for translocation. And every year prior to beginning translocation, we would meet with the Lamprey Committee and they discuss with the tribes what their plans are. We get our permits and go forward with collecting. And we'll weekly submit updates to regional partners if they're interested in knowing how many we're collecting every week, etc. All right, so now when we get to here, so we have to monitor and make sure it's actually working and that just picking these fish up, translocating them upriver, that they're actually successfully spawning. And so this is where the next part of the presentation is where I'm going to get into the results of some of the genetic analysis. And just looking at the time, yes, we're good. We're doing good. So I'm going to transition over in the next part of the presentation. I'm presenting on my colleague, Jon Hess, his presentation. So I may kind of go a little slow through it because some of it is a little bit, it can take a little bit to describe the slides. It's a lot of graphs and everything, so. And yeah, so you'll find it's interesting. And like I said, it's a good news story. So those are always great to have because sometimes it's hard to not hear too many good news stories. Okay, so this is my colleague Jon Hess developed this presentation. And so some of these results, these were published in a paper if anyone's interested, the return of adult Pacific Lamprey offspring from translocation to the Columbia River Basin. So what were the major results? We were looking at the fish from the upper Snake River Basin in this, so that's why we're talking about that. And we could determine precise natal origins. We determined that Snake River juvenile production is increasing, that Snake River origin adults do return to the Bonneville Dam, to the Columbia River, and Snake River translocation adults return to Bonneville. So offspring of translocation go out and come back as adults and end up back at Columbia River, the Bonneville being counted. And the run at Bonneville may reach a 10-year high coming up. All right, well, how do they determine precise natal origins? And what are we doing? We have a baseline of SIB-SHIP of 59,575 samples. So SNPs, just little fin clip off of the fish collected in all these locations. So CRITFC coordinates with agencies all over to ask, hey, if you have your hand on a fish, you know, because it doesn't hurt them. It's just a little tiny fin clip. And so we've managed to get 59,575 samples to date. And then for the translocation, 100% of the adults that are translocated and released have a genetic sample taken. And that way that's tagging them. We can track them and their offspring into perpetuity almost. And so using their 259 SNPs, he said, since that article was written, they've added a few more samples. So some of the results are brand new. They're not in the article. And they included another 29,000 fish from Bonneville. So taking the information they learned from the SNPs from all the life stages, and then having to say, okay, can I predict abundance? If I look at larval juvenile out migrants counted, and then looking at adults coming back and then putting the two together. Okay, so the article that's that I just referenced included the years 2011 through 2018, and this these are counts extrapolated from the counts at this is abundance extrapolated from the counts in the smolt monitoring program at the Lower Granite Dam. So these are live fish out migrating. So these are juveniles out migrating. And so as you can see, all right, it looks like there's some years are high, some years are low, but 2018 looked pretty good. It was 50,949. So that was looking good. And then we received the last 4 years of data and extrapolated that. And in 2022, there was a high of 378,740. And that's super. So then we take that information and then we ask the question. So, all right, do fish, sorry, I want to get this right. What we're looking at here is natal origin Snake River Basin, but not translocation offspring. So this is natural offspring. They've been counted heading out in 2011. That's the black bars. And then the yellow bars are what we're going to expect to see returning adults. And so we're going to move forward and so this helps putting the clicking on a little further to describe it. Okay, so juveniles going out in 2011 converted to that many adults, and the reason we knew they were, that was through SIBSHIP. So fin clips off that fish matches, okay, as a sibling, or you know, it might have been an offspring to one of the translocation adults. Not translocation. Right now we're looking at these slides are natural running, not translocated. So you can see they're increasing at Bonneville Dam, and that's expected. As you recall, like we said, like they might spend 5.5 years in the ocean. So it takes time, you know, to start seeing the bump up. Well, and then we learned, yes, ocean residence time was approximately 5.5 ocean years. What else did we learn? We were able to do we as in CRITFC, Jon Hess and his people were able to do this model and this juvenile to adult return. Now came up with 1.58, but he said this is just a proxy, and so we'll have to see. Okay, but for this year's, all right? And then looking at the Snake River translocation, so now we're looking at comparing the offspring of the fish who are translocated and released versus the offspring of naturally migrating fish, and comparing the two to ensure that what we're doing is working. And so in this slide, we can see that the yellow bars, so volitional offspring are in the black and translocation offspring are in the yellow. And so each year we're seeing an increase, but it's not each year an increase. And to explain that is because if you remember the slide, I probably should have put the graph of how many fish were translocated per year, but so you have to look at the variability is variability based on how many were actually released each year too. So there's variability there, but overall we're seeing this increase now as we continue to release more and more fish. And after that period, that's going to be up to 20 years. You know, when you add the 10 years, a fish could be 10 years in the sediment. It could head on out 11 years, then could be out for 5.5 years. You know, that's 16.5. And then maybe they come back and they spend 3 years instead of 2. So we're looking at these really long time frames to have to understand. So brand new here information is that, yeah, we're seeing increases. And now we can guess, well, estimate how many adults might be returning that are offspring of translocation adults. And that's where you see these. So in 2014, he expected a certain number. And in fact, we saw that number moving forward. It continued. And as you look at each, those are the larval outmigrants. On the right is the adults. Continuing to go up now, people go, why is it dropping off? That's because we don't have the data that goes forward. So we could almost put something there so it doesn't look like it's dropping off. But the key here is that the brand new information is we're going to expect to see an all-time high of translocation offspring adults returning back to the Columbia River. And I did say they don't home to their natal streams per se, but there's a affinity to return into the general locations where they were their natal locations. All right, so by 2027, we could see 4,900 Snake River translocation offspring return as adults, which is a really high number. I mean, maybe it's sometimes in the salmon world that might not sound like a high. This is a really high number. This is, you know, we're making some progress. And then when we look at Snake River translocation adults returning to Bonneville, so we looked at migration year 21. He was able to look back, check on that, check the model, check the predictions, and sure enough, so there was an 89,000 in 2021, 83,980 adults returned. Out of those, after the genetic analysis, it was shown that 1,065 of those fish came from the tribal translocation programs. And now we're adding in the other programs because in the next set of data, all the data has been analyzed. So the offspring from the other two programs is also included. They didn't start the genetic sampling as early or for 100% as previously as the Nez Perce tribe did, but now all since 2013 do all of their fish. And so now 2022 was looking at a prediction. Did the prediction come to be so? Yes, the prediction came to be so. And so the run size in 2022. Now, let me note that the Army Corps of Engineers does correct all their counts randomly throughout the year. So I'm saying the 114,291, it might be 114,391 or something. No, it's not going to be that, but different, but it might be 114,297 or something. So just, you know, if you see something that says a different number, it's just that we occasionally have to correct. Not that others would be looking at that, but you never know. So here is migration year 2022, and how many of these were offspring of translocation adults? 2,200. So, you know, we're looking at each year more and more. And so this is good news, but we also know they're out in the ocean for maybe 5.5 years. So we have our predictions, and then so the questions were, does what go in come back out? So we're answering questions. Did it, you know, how did it work? So yes, our migration year cohorts proportional, meaning if a certain fishes are all their siblings and them also migrating in similar time frames, and the answers will be in the next slides. Do they have the same ocean duration? Is there the same percent translocation, same composition of spawn years, and same composition of release groups? Well, migration year cohorts proportional. So yes, they are. A nice graph here. How about same ocean duration? There is some variance, what you can see here, which we already said there is variance, but for these cohorts, the average was about 5 to 6 years before they're seen at Bonneville Dam. So we're giving it a 5.5-year average. And then as far as percent, the translocation fish are maintaining the same abundances. And so, you know, looking at that and will continue to ensure that this is working. And then as far as same spawn years, according to what left lower granite, there should have been high abundance in 2007, 2008, and 2012 relative to 2009, 2011, 2013, and 15. So was there? Yes, there was. So there we go. That's a that was a yes. Now this one, I can't really say a lot about it because this is just the actual release group. So that's their names, that's their titles. And so it says there is a high level of resolution. It's not a perfect fit, but there's a high level of resolution. So we're giving it a green check mark. And then Snake River origin adult model predictions at Bonneville Dam. So now we're going back to the model, the predictions of what may come back. And we look at the ratio of Snake River origin adults to the total Bonneville adults. And the same average value is observed in the years from 2014 to 2022. So if you look at it's a little messy, but you can, the colored lines show the years. And so we're looking at the total snake is the black one. That's total translocation and volition. All right, so here's the good news. We're seeing we are seeing a steep increase in the numbers of total adult returns, and could see a 10-year record high of 450,000 fish by 2027. And so that's great news. And that is the end of my presentation. Oh, that's not the end of my presentation. So that's the end of the presentation. Thank you.